Welcome friends, this is Atanu Chaudhary of SureSolv. Continuing from the first part, in the second part of the video, we'll solve the last 5 questions of SSC CGL Solution Set 57 on Algebra 13 from SureSolv.com. Let's start solving the first problem. Analyze the problem for the solution. Two straight lines on XY plane can intersect at one point or be parallel or be non-unique. If the ratio of coefficients of xy and the numeric terms are equal, the lines are not unique. At the first step, check the uniqueness of the two lines by rearranging the terms properly. 4x minus y minus 2 equal to 0 and 8x minus 2y minus 4 equal to 0. Multiply the first equation by 2 and you get the second equation. The two line equations are not then unique and the solutions are infinitely too many. Answer is option D, infinitely too many. Solve easily in mind by mentally rearranging the terms of the two equations. Let's solve the next problem. Go through the problem and try to find a way to solve it. Identify the first key pattern as the difference between the square of the two terms for each of A, B and C is 1. For A, square root of 6 whole square minus square root of 5 whole square equal to 1. For B, square root of 5 whole square minus 2 square equal to 1. And for C, 2 square minus square root 3 whole square equal to 1. Then the second key pattern as the first and the second equation as well as the second and the third equation have two common terms but of opposite signs. And lastly, identify the third key pattern as the surd expressions are subtractive sum of surd terms. As subtractive sum of surds cannot be directly compared, guided by the patterns you have discovered, you would invert each of the subtractive sum of surds and rationalize to convert to additive sum of surds. With one term common between a pair of converted additive sum of surds, it would be now easy to compare the values of the pair. Let's show you. Inverting and rationalizing the first sum of surds for value of A, you get 1 by A equal to 1 by square root 6 minus square root 5. Rationalize the denominator by multiplying and dividing the RHS by square root 6 plus square root 5. Result is 1 by A equal to square root 6 plus square root 5 as denominator result is 1. Similarly, 1 by B equal to 1 by square root 5 minus square root 4 equal to square root 5 plus square root 4 and 1 by C equal to 1 by square root 4 minus square root 3 equal to square root 4 plus square root 3. One by A and 1 by B have square root 5 common and square root 6 greater than square root 4. So 1 by A greater than 1 by B. Similarly, 1 by B and 1 by C have square root 4 common with square root 5 greater than square root 3. So 1 by B greater than 1 by C. Combining these two results then, you have 1 by A greater than 1 by B greater than 1 by C. Inverting the variables inverts the comparison relations also. So invert the comparison results of 1 by A, 1 by B and 1 by C to get the comparison results of A, B and C as A less than B less than C. Answer is option C, A less than B less than C. If you know how to solve this awkward problem, solution can be quick. Let's solve the next problem. Analyze the problem to find a way to solve it. As there is no constant on the value of x and you have one term in the given expression as 1 by x square, with x equal to 0, the maximum value of this expression can only be indeterminate infinity. Answer is option D, none of the above. Next problem now. Go through the problem and think how to solve it. We need to find the value of x by y from the given expression by cross multiplication and simplification. It is expected that the ratio will be a perfect cube. Cross multiplying the given expression, 10x plus 15y equal to 18x minus 12y. Or 8x equal to 27y. Or cube root of x by y equal to 3 by 2. Converting the target expression in terms of this ratio and substituting its value, you get 3 by 2 plus 1 divided by 3 by 2 minus 1 whole square equal to 5 square equal to 25. Answer is option A, 25. With the right steps, you can solve this awkward looking problem easily and quickly. Let's take on the last problem. Analyze the problem to see how to proceed. By component expression substitution, substitute dummy variable p equal to x to the power 12. The given and the target expression immediately are simplified to p square plus 1 divided by p equal to 7. That is p plus 1 by p equal to 7. And p to the power 6 plus 1 divided by p cube, that is p cube plus 1 by p cube. This is now a simple problem of evaluating a sum of inverse of cubes from sum of inverses of unit power. You have done pattern discovery and suitable dummy variable substitution to convert a more difficult problem to an easier problem. The modified two-factor expansion of sum of inverse of cubes of the target expression is p cube plus 1 by p cube equal to p plus 1 by p multiplied by p plus 1 by p whole square minus 3 equal to 7 multiplied by 49 minus 3. Equal to 322. Answer is option B, 322. Solve quickly and elegantly with pattern discovery and suitable methods. To read the detailed solutions, refer to the corresponding article in our website SureSolv.com. The link is given in the description of this video. Thanks for watching.